Hello, my hosts, and welcome to another programming slash editing live stream. Today we are working with an anim, I don't know actually how you pronounce it, in order to do a little bit of animation and programming for my lambda calculus video. So let's get into that. All right. If you're using me now, put device is not a TTY. That shouldn't matter. Try prefixing the command with win t. Okay. Where does it want me to prefix that? The entire command? Win t. No. Okay. Let's remove that and do a Google search for that error message. Input device is not a TTY. Is it a Docker thing? Okay. Oh, remove the IT. Let's remove the T, see if that helps. All right. My choice is... that doesn't work. So I need it to be interactive. No error here. Kill that buffer. Yep. Gee, that should make it run fine. Except for the error. Okay, cool. We can deal with that. Oh, yeah. That's fine. Because we didn't actually finish that properly. Okay. Yeah, let's click back to you. All right, I've got a little searchy here, and what I'm searching for... fixed point combinator Y. Go. Copy this derivation out. All right. stick an @ symbol there. And an @ symbol. Let's add a comment. What's comments in @0? This step 1. All right. So go like that. We go dash dash. We have another term there. Oh. Okay, YG. Why is there a red green there? Okay, there's a right. We want to copy the entirety of that into there. All right. Then the next line that, remove all of that, but leave that bit where we substitute in the G constant. All right. Replacing every instance of F. So, guess we can open brackets like that. F. So, that maps to pink G that remains unchanged. That goes like that. Pink G white. Green exit there. Right. That we don't need that pink G there. Oh, dokie. That comes across quite fine. Now, copy the bit where I do the array thing. Why do I do the array thing? It's array 1. There we go. Add 1, 1, 1. That's fine. Okay. Do that. Paste that one in there. And copy that. All right. Perfection. We get error messages. Info. Good. That looks like it worked. Now. I'll go here and we'll check out the video that was made for it. You can't see this, but I can. That's kind of a problem. Just going to copy a pink G into place. Okay. What would look better? If that was 2. And 1 repeated that. With a second line, like that one. Okay. Alrighty. There. I wonder if there's any way to make showing these things easier. All right. Recompile. Sure, YG is something significant. Like it's a immune factor or something. Okay, we'll find out at some point, I'm sure. Okay, let's view it. Not quite. I need... So a second. There it goes. Okay. Go. Donk donk like that. There we go. All right. Try that one out for size. That's doing it stupidly. Okay. Then acts like a dumbass. Okay. What if we skip stage 1? Comment region. Recompile. Okay. Not sure how... I'm continuing to be inflicted with ants. Get rid of that. Okay. Yeah. I might have to do it the non-fancy way. Just do the last bit of the cycle. And use some other means to get through this. Okay. Check my references to make sure I'm doing this right. Yep, we beta reduce. Here. Right, copy. All of that. Okay. G. Double bracket. Okay. Let's just do this raw. to GXX. Double racket. Racket. X maps to GX. Again. Triple close. Okay. Compile that. Okay. Yep. Mm-hmm. There's no bracket there. And final bit is GYG. Okay. Oh! GYG is the is the local Mexican place. Gomez and Gomez. There we go. All right. That makes sense. Alright, let's get the... like that. G. Math ball face. There. Hi, New Haven. Thank you. Open brackets. Like that. Oh, should stick an R in front of that. Close bracket. Okay. Thing is, I might have to cut out all the extra work we did. Okay, now I'm going to comment out this. I'm going to probably have to record new audio for this animation as well. Yep. I'm using Windows mostly because all my VTubing software is set up for Windows. Okay. Right. Even though it does make programming a little bit more tricky. Okay, that's compiled. I'll take a quick look at it. Oh. I missed a bit that I didn't comment. Oh, there it is. You. All right, there. Comment that region. Okay. Making iterative improvements that you can't see, but perfect. All right. Let's copy and paste that in to the card. Get that. Okay. And miniaturize that, and also put dual screen. Copy that like that so you can see what I'm editing. Subtitle track smaller. All right. Input. Copy this over in place. Now you can see all of that. Good. Let's get into the right place for the audio, because we're going to have to record new audio for this anyway. But if we feed the Y Combinator a dummy function, you can see how it ends up with G being passed into G. Okay, I'm going to say, if we feed the Y Combinator a dummy function, like that. Okay. Split off that. We use Control Y to select everything after the point. Okay. Slide that over there to give us some room. This whole thing will be its own thing, I suspect. So I'll record new audio for this bit here and get the timing and everything right. Actually, it probably is going to be done in a new clip. So just undo that. Click on there. Create new timeline. Yep. All right. That's our... Yeah, and we'll rename this timeline from timeline 10 to YG animation. Work out how that comes out later. Back to the main timeline. Where's the main timeline? Jumping through timelines sounds like I'm doing some sort of sci-fi thing. Okay. You can see how it ends up with G being passed into G. This is a type of fixed point where the function going in is the same as the function going out. I always find... All right. There we go. I always find examples to be helpful. So let's try and implement the factorial. So how would you implement this? The factorial. Okay. I'll probably need to draw up an example of what factorial is, rather than just assuming people understand what it means. Okay. Let's go back to this one. We can do it another lambda. Oh. Another bit of Python texty type stuff. Yeah, and I know copy and pasting is a poor method of code reuse, but it gets the job done often rather than abstracting things away. All right. Oh. Keep on saying Factorio rather than factor. Now. I keep saying... Oh, now I've gone and broken my brain. Rather than rather than what is the... Now my brain... factorial. Oh. 6. Bang. Okay. What's the... Oh. Bang function. What do you call... Bang function doesn't exist? Okay. Ah, factorial. Factorial. I keep on saying factorial. I don't know. Are they pronounced the same way? Is the game pronounced the same way as the math function? So, math function. Factorial. And the game... is yeah, it's missing the L. Oops. Factorio. Yeah, I agree. New Haven. Okay, let's... Factorial. There. Let's write a definition of factorial. So N bang equals... Actually, I can just probably not have to... I do want to actually color in the variables. So let's go green N T oops R bang equals N in brackets. Get rid of all this extra guff. Okay. Close brackets, open brackets. Keep hitting wrong keys. -1. Close brackets, open brackets. -2. ... Two, 1. That's one way to express it. Yeah. And the other way you say factorial is a pair of recurrence relations equals oh no, did I say n bang equals n bang? Oh, that shouldn't be there. Right. That. Equals. Open brackets. N -1. Close brackets, bang. Oh, we need an N over here as well. Okay. I've missed a quote mark somewhere, and that somewhere is there. All right. And we say zero bang equals 1 by definition. What's my project? I am doing an introduction to lambda calculus as way of introducing, in turn, type theory and a few other things I find interesting along the way. Oh, and I'm going to have to compile. That is supposed to be starts with a capital letter. Compile that. Always worrying when things compile off the top. That's weird. Something's wrong with my LaTeX. In particular, I've written it wrong. Can't blame... There, that's better. There it goes. All right. Perfect. Now copy that into there. We'll import our animation into the project, and we can cut and paste it. As soon as I find it. Okay. That will be standing beside me. I always find examples to be helpful. So let's try and implement the factorial. Good. Zoom. Reposition. There we go. All right. And implement the factorial. So, how would you implement this? The easiest... go into here. Open Infusion. Go to the end of this. That's F for a transform function. Blow the size up till it fills the entire screen here. Oh, okay. That's too big. Let's shrink that down then. Hold on, it goes off the screen? Even in the original rendering? Oh, that's gonna... That bites. Okay, let's deal with that later then. All right. Get rid of that. Remove that marker here. Bright red marker to indicate that I've got to fix something. And I'm going to say clip breaks the last one. Fix me, please. Alrighty. So, how would you implement... Hold on. Oh, it doesn't. I just didn't go far enough. Okay. That's fine. I don't need that then. Factorial. So, how would you implement this? The easiest way is to make use of what I call the recursive algorithm. All right, go back by one. Oh, go back by one frame. That's not one frame. That's one frame. Get that. Go into change. Clip speed, switch on a freeze frame. Scroll that out. Easiest way is to make use of what I call the recursive algorithm. This method allows you to work out how to create a recursive algorithm for even the most complex of tasks. In this method, first you try to solve the simplest case. Okay, so I'm gonna whack on a little blackboard here. Okay, let's go Fusion Comp. Oh. Don't want a Fusion Comp. Actually, you want an adjustment clip. In this method, first you try to solve the simplest case. This is your base case. Then you work out a way to take a step towards your base case. This is your recursive or inductive step. So for there, move that out to there. All right, just checking on the stream. How's the stream going? Stream looks fine. That's good. Alright. Open that one. There. Hello, your background. Bring the size of the background down. Move it across. We're going to have text plus. All right. Go for that hyperlegible. Right. There. I'll go with them. That's spelt wrong. Tis. Oh. Mr. Algorithm would be ashamed of me for misspelling his name. Although it's... don't think either Mr... well, Algorithm is a corruption of his name. And I think the prefix al, in this case, acts a bit like Mr. anyway. All right. Step one. Oops. Solve the simple base case. 2. Create a step that produces things closer to the base case. Actually, base. Solve the simplest case. Induction. Reduce complex case towards the base case. All right, stick a space between that. Character level styling. It select the U and stick an underline under it and increase its size. Let's see if algorithm copy algorithm. There we go. Actually, I want that bigger. Ruins the illusion that that's a blackboard if the words clip out of it. How you been going, Azure? I hope it has been well. Okay. Now we get to the animation. First, you try to solve the simplest case. step. All right. This is your base case. Then another keyframe there. And you work out a way to take a step towards your base case. Expand that one out. All right. How does that come out? Even the most complex of tasks. In this method, first you try to solve the simplest case. This is your base case. Then you work out a way to take a step towards your base case. This is your recursive or inductive step. So yeah, that strange audio distortion you might be hearing is because we're playing it back inside the editor rather than anything else. But that is going fine. So for factorial, we will need to start with some basic boilerplate. Since it's recursive, and this will get a little bit more complicated, and I'll have to do some Y programming, not Y programming, lambda programming in here, which I think I'll do off screen. However, I think we've gone a little bit over time. So what I can say is, hold on. Ah. Why am I so big? What? Normally I'm not this big, am I? Anyway, thank you everyone for joining me today as I did some editing. Tomorrow we will be doing some Minecraft. So I hope everybody can join me for that. As always, if it's the first time watching, please subscribe. And I hope to see you later. Goodbye, everyone.